So this video explains the calculations for part 3 of the thermochemistry lab, the Hess's law portion. Here's what we know so far. We did an experiment. We figured out the heat of reaction, change in enthalpy of the reaction, for the reaction between solid magnesium and hydrochloric acid to make aqueous magnesium chloride and hydrogen gas. And you have that number. You calculated it previously. We'll call that delta H1. You also calculated the heat of reaction for the reaction between solid magnesium oxide and hydrochloric acid to make magnesium chloride, aqueous magnesium chloride in liquid water. You know that. You calculated that previously. We'll call that delta H2. The goal of this part of the experiment, or the calculations, is to find the change in enthalpy for the heat of formation for solid magnesium oxide. Remember, the definition of the heat of formation is the energy change, the change in enthalpy for the formation of 1 mole of the substance from its elements in their elemental form. Magnesium oxide comes from, the elements are magnesium, which is a solid in its elemental form, and oxygen, which is a gas, and it's O2 in its elemental form. So this is the equation we need the delta H for. That's the heat of formation of magnesium oxide. That's our goal. So what we're gonna do is manipulate these equations so that we can try to add them up to be this, but we need one more equation. And this I'm gonna give to you because we can't do it experimentally, not right here. So this is what we need. And this is a given. So that is the heat of reaction for this reaction is negative 285.840 kilojoules per mole. I got this just by looking up the heat of formation of 1 mole of liquid water and reversing the reaction, which means I changed the sign. So what we're going to do now is try to manipulate this equation, this one, and this one so that they add up to be equal to this one. So what I'm going to do is I'm going to write the first reaction just as we did it, and we know delta H1, we calculated that already. I'm going to take the second reaction we did, and look, this is just the reverse, right? And in the second reaction we did up here, react to magnesium oxide with hydrochloric acid, and got our delta H2. What is reverse that? So when you reverse a chemical equation, all that happens is you change the sign of the change in enthalpy for that reaction. And this I gave you. Now if we add up these three equations, look what happens. The magnesium chloride cancels. The hydrogen cancels. And the hydrochloric acid cancels. And the water cancels. And what we have left is what we're looking for. Oops. This reaction describes the heat of formation of magnesium oxide. And because we got this reaction by adding up these equations here, we can get the heat of reaction just by adding up these delta H's. So again, you calculated delta H1, the magnesium part of part 3, delta H2 in the magnesium oxide part of part 3. This I gave you. Just make sure you get delta H1 and delta H2 in the right units. Convert them to kilojoules per mole. Plug them in here, and you'll have the heat of reaction, which is the heat of formation of magnesium oxide, which is what we're looking for.